All right, today we're going to be talking about graphing square root functions. So we're going to graph and analyze square root functions. And we're going to graph and analyze square root inequalities. So we're going to do both of them. Now we're going to talk about what a square root equation looks like, or square root function looks like. When we do these, we're always going to talk about what's called the parent graph, the most basic form of this function. So the most basic form is f of x equals the square root of x. There's no pluses, there's no minuses, there's no times, nothing else like that. And if you were to type that into your calculator, you're going to get this kind of a graph right here. As I said, it's the most basic form of it. Notice there's a starting point, and then it goes up kind of like a quadratic. And actually, it's very similar to a quadratic. A quadratic is a U shape that would go like this. But if we took the U shape and tilted it on its side, it would actually be the same graph here. It just doesn't have the bottom part. Notice it's missing that because we can't have the square root of negative numbers. And the square root of negative numbers, of course, is the i's and things like that. So we can't really have, these are not available. So it kind of has a starting point, and this starting point is going to be very important for our domain and range. Notice the x value is 0, and my domain is x is greater than 0. The range is 0, so it's y is greater than or equal to 0. The intercepts are where it crosses the x-axis, although it's 0, 0. They won't always be that. We're going to be much more focused on the domain and range, and that comes from this point here. And I'm going to show you how we go ahead and do that on more graphs besides just the parent in just a moment. But that's where this comes from. The domain and range comes from where that starting point is. All right, and then we have some end behavior. As x approaches infinity, it goes to positive infinity. It's going up. All right. So this is the more difficult or the more complicated form of that exact same formula. So f of x equals a times the square root of x minus h plus k. So this is when we have all of the things in there, when we have pluses and minuses and multiplies and things of that nature. Each of these things has a special part to our equation, and we'll do different things to our graph. And we should be able to know from the way that this formula is laid out and the numbers that get put in what our graph does. And we should actually be able to graph it without our calculators. Obviously, we have them and we're going to use them. That's not a problem. But we should be able to tell information just from these just from the equation when it's set up in this form. Now, this equation, or this form of the equation, is what a lot of the second semester is going to be on. We're going to keep coming back to this minus h and plus k information over and over and over again. So we need to get used to that idea. And they're always the same. This horizontal translation, the h goes ahead and moves it to the right or left, depending upon which one. Now notice, because it says the minus, it's opposite. So an x minus 2 will actually move it 2 to the right. An x plus 2 will move it 2 to the left. I'll show you that on our first example. But because of this minus here, it's always opposite, and the h will tend to do that. The k on the other side, it's plus k, and that's positive. So a positive value is going to move the graph up. A negative value will move the graph down. And remember, we have this starting point. So this starting point is going to be moving up and down and left and right. Up and down and left and right, depending upon these h and k values. Now, what does the a do? A is kind of like the slope. So if it's negative, it's going to go the opposite direction. You know how a negative slope goes down as opposed to going up? Well, the same thing's going to happen here. We're going to have a graph, instead of going up, it's going to end up going down. Also, we can go ahead and make it bigger, or we can either expand it or compress it, depending upon the different values that we go ahead and do. So let's go ahead and look at some examples. So we need to find the domain and range of this one. Now, the values that we want to go ahead and look at are the values on the inside and what we're adding to the outside. If you notice, we're not adding anything to the outside. What we add to the outside is our y value. So the y is the range. That doesn't change any. So in our basic form, y was greater than 0 was our range. Well, there's no plus over here, plus or minus over here, so this doesn't change. The one inside the square root that's going to change our domain. It's next to the x. That's how you should know. But remember, I said it's opposite. So this is -2. So you would think it would go 2 to the left. It actually goes 2 to the right. So where's my domain at? It's going to be greater than 2 because it's 2 to the right. So that starting point that we have, I'm going to move 2 to the right here. And I'm not moving it up or down any. So it's just going to be this graph, but moved over 2 and then going up like that. Well, let's take a look at that. So we go ahead. The best way of doing this is just setting this equal to 0 and solving that, and you can get x equal 2 and see when you move that over, that's why it becomes positive. So by setting this equal to 0, you can find that value. And so the domain is x is greater than 2. And the value for the other one is just at 0. So let's try another one here. So we have this +4. So again, remember it's opposite. This is just kind of like a slope, but it's not going to change where we start from. This is going to change our start. There's nothing to be added out here, so it's still y is greater than 0. In here, we're going to talk about -4. So we got greater than -4, but also greater than 0. All right, how about this one? The domain is going to be +4. So it's going to be x is greater than 4. And the range now has a +2 here, so we're going to go up 2. So the domain is x is greater than 4, and the range will be +2. And that's, if we were to go ahead and graph it, that's where our starting point is going to be. And if we look at the graph, now they did a table of values. I would just put it in your calculator. Look at where we start, at that 4, 2. That's what this whole value said, that would be +4, and this would be +2. So we're starting at a 4, 2 point. So 4, 2, and then our graph goes up from there. And so our domain is x is greater than 4 and y is greater than 2. All right, here's another one. So here's that +5. So the +5 is going to make it -5. The -6 is going to make it down 6. Now, one thing we do have to worry about is this negative. This is the first one with a negative. And what that does is it means that it goes, the graph, instead of going up, let's go back, instead of going up like this one, it's going to end up going down. So let's have a starting point of -5, -6. So there's our starting point, -5, -6, and now this one goes down as opposed to going up. Again, you can type that in your calculator. That's fine. I have no issue with that. But to find this point, we're going to have to look at those points. So when we're talking about the domain, x is greater than -5 and x is less than -6. All right, let's take a look at these. We have a +2 here. Again, it's opposite, and then a -3. So I want to go +2 and then -3. +2, +2, -3. This is the only one with the correct point, and the 3 does mean that it goes up a little bit faster, just like a slope. So this is most assuredly what we're looking for, D there. Yep. All right, what about this one? Domain is -1, and x is always greater than -1 no matter what, so they're greater than the -1, so we're talking about these two. But now notice this negative. That again means it goes down. So when we're talking about the range, we have this -4, but it's going to be below that, so less than -4 because the value is going down. The range will switch sometimes there, so we have to be careful with that. This is +4, so we want the -4. So here it is with A. All right, notice this one. We're going to do some inequalities now. So greater than, so we do need a dotted line. Notice nothing's being added here, so we're still on the x-axis. There's no plus. Notice this one here. It has a 3x plus 5. So to find this point, we would actually just set 3x plus 5 equals 0, and we get -5/3. So this is -5/3 is what we ended up going. And because it's a plus, we're going backwards 5/3. It should be dashed because it's a greater than, and then we're going to fill it in. So it's greater than, so where are all the points greater than? Greater than would be on top, less than would be below. Now be careful when we do this shaded area. Oops, sorry. Notice the line here that it stops at. It will always do that. Again, you can type this in your calculator, and your calculator will show you this graph. That's great. But you need to understand how we got this point here. And because of the values over here, if I put in a value of 3, I'm sorry, negative 3, that's negative 9 plus 5, which is negative 4, which is the square root of a negative, which is an I, which is imaginary. So these values over here are imaginary, so we don't want to use any of them. So that's why the shading part actually stops. And it's all these points up here. So be careful of that. Understand that the shading does have to stop. All right, so this point, there's no pluses on the outside, so we're staying at 0. And then we're going to solve this. We're going to subtract 4, so it's negative 4 divided by 2, so negative 2 is where we start at. So this one here starts at positive 2, positive 2, nope. This one's a negative 2, and this one's a negative 2. Now it's greater than, so we want the ones on top. So we're talking about D. And that's what I have for you today.